Hello everyone, welcome to lesson number 20. Today we're going to learn about the ultrasonic sensor. Okay, so now let's open our info slide. So ultrasonic sensors work by emitting high frequency sound waves, typically in the range of 20 kHz to 40 kHz. They actually used to measure distance between the sensor and the obstacle. So basic components we have transducers, which convert electrical energy into sound waves and vice versa. So we have this one for transmitting and this one for receiving. We have an oscillator which generates the high frequency sound waves, which is this one, and we have the microcontroller which processes the received signals and actually calculates the time this was a mistake. So from the echo pin, which is this pin here, we will record time taken by the sound wave to travel to and from the obstacle. The time will be in microseconds. The speed of sound in air is 443 meters per second, or 34,300 centimeters per second, or 768 miles per hour in different units. It's just looking for this. We have the VCC, which is the power pin, and the ground to complete the circuit, and the trig pin which will trig the transmitter to transmit, and then echo pin which will receive which will record the received time from the receiver. Now, so to calculate distance we shall use this formula. So distance is equal to speed times time. So this is the speed we have taken in centimeters units. So speed here, and the time, I've divided the time by 1 million here because it's in microseconds. Dividing by 1 million makes it in seconds, divided by 2 because this is the time recorded is from 2, then from. So only what we want is just the distance, so we have to divide that by 2, and the distance will be in centimeters. Okay, so now let's get to our connection page. Okay, so here we have the breadboard, the Arduino, and our ultrasonic and some jumper cables. I'm going to start by mounting our ultrasonic to our breadboard there, like that. And then I'm going to start connecting wires. For white, I'm going to use it as the trig pin, and for the red one, I'm going to use it as the power pin. The orange one, I'm going to use it as the echo pin, and the black one, I'm using it as ground. Okay, so I'm going to connect the 5 volts power supply to our 5 volts on our Arduino, and the black wire to ground just right beside it. And the white one to pin number 9 on our Arduino, and the echo pin to pin number 10 on our Arduino. Okay, so now we are successfully hooked up. Let's go and write a code to operate our ultrasonic sensor. Okay, this is our Arduino off. This time I've actually already written the code in order to save time. So as you can see, the trig pin, which is on pin number 9 on our Arduino, which is in white, the echo pin on pin number 10 in our Arduino. The travel time, this is the time we are going to read from our echo pin, and finally the distance, which might be a decimal, which I have declared using a float. We are going to calculate this distance after we get our travel time. So in our void setup, we'll call our serial monitor, and that's our baud rate. Pin mode of trig pin is output. Pin mode of echo pin is an input, since we are reading from it. And under void loop, we have we're going to do a digital write to the trig pin, setting it low just to make sure nothing is being transmitted. We are going to delay for 10 microseconds. Then we have to read it high so that it transmits, and now we delay for 10 microseconds, and now we do another digital write to setting it low so that it stops transmitting. And our travel time is going to be pulse in echo pin, setting it high so that it starts to receive. And our distance, you're going to calculate it by speed. There's a difference between this formula and this one which you are seeing here. I've just written it a little bit differently, but in maths it's this one and the same thing. So the reason why I've done this is because if you start by dividing the travel time by 1 million, Arduino works in like 2 decimal places, so there will be many zeros before actually to the actual values. So Arduino just recorded 0, and having a 0 here would imply another 0 here and another 0 here, so the distance will be recorded as 0. But if you first treat it like this, then divided by 1 million later, the answer would not be 0, and then dividing it by 2 is just so that we get the actual distance, the one from 2 and so. And this is a serial print distance, serial print new line centimeters. This is just writing the units, delay for half a second, and we now repeat the for loop again. So now I'm going to upload our code to our Arduino. Okay, so our code has been compiled and now it's uploading and done. So now let's go on our serial monitor. Okay, so now that's the reading. So right now I'm going to put my hand in front of it. Okay, and it's saying approximately it's 5 centimeters. I'm going to put a little bit closer, 2-3 centimeters, a bit closer. I guess it's not reading anything too. Okay, now let's move it far away. 3, 4, 5, 6. Now I'm going to fade away. Now it is shifted to 9, 10, 19, maybe a little bit further, 15, 13. Now I'm going to move it a little bit closer again, 9, 8. So there we have it. We are now measuring distance using our ultrasonic sensor. Thank you for following this tutorial.